Hi all. So SN1 and SN2 products are same in SN1. So what is there in SN1? SN1 there is a carbocation formation there. Carbocation means it's an intermediate there. Carbocation, which carbocation is more stable? Tertiary carbocation is more stable. For becoming tertiary carbocation, there will be rearrangement happens inside that compound. SN2 means what? Backside attachment, you know that. Is there any intermediate there? No, there is no intermediate there. No intermediate there. If there is no intermediate, there is no rearrangement happens there. No intermediate means no rearrangement. So SN1 and SN2 products are same in which one means if there is no rearrangement happens here also, that is in SN1 also there is no rearrangement happens, then this one and this one will become same. So actually the meaning of this question is what? In which of the following reactant there is no rearrangement happening during the reaction. So we can check that. So carbon chlorine bond, nucleophilic substitution means this bond will break. At that time this carbon will get a positive charge. Positively charged carbon is attached to two carbon, so it's secondary. How can it become tertiary? Take one hydrogen from here. There was a hydrogen here. Take that hydrogen to this position. At that time, here it will become plus charge. So it's a tertiary carbocation. So rearrangement is happening there. So you move to this one, second one. You break the bond between carbon and chlorine. At that time, this one will get a positive charge. That's a primary carbocation because positively charged carbon is attached to only one carbon, primary carbocation. Less stable. Therefore, here there was a hydrogen there. That hydrogen will shift to this region, hydride shift. At that time, that positive charge will shift to this position. Now it will becomes what? A tertiary carbocation. So here also rearrangement is there, here also rearrangement is there. You move to fourth option. You break the bond between carbon and chlorine. Here it will become positive. Positive charged carbon is attached with two other carbon. So it's a secondary carbocation. You know that tertiary is more stable than secondary. But here there is another one thing, that is this hydrogen will shift from here to here. That's hydride shift. Now this carbon will get which charge? Positive charge. Why this thing happening here is positively charged carbon is attached with pH. What is that? A benzene ring. Positively charged carbon is attached with a benzene ring means there will be resonance happening there. If resonance is happening there, the stability will increases. So that's why definitely this rearrangement will happens there. Now you come to this third option, carbon chlorine bond. When you break that bond, this region will get which charge? Positive charge. Positively charged carbon is attached to two other carbons, so it's a secondary carbocation. You may think that there is a shift happens. What will happen? What will be the product? So if you shift this hydrogen from here to here, the positive charge now shift to this position. This is also a secondary carbocation, so no use. So if you shift a hydrogen from here to here, then also same thing, positive charge, no use. Positively charged carbon now also attached with two other carbon, secondary carbocation, so no use with that. Therefore here there is no arrangement. So which one does not have any arrangement? Third one. No arrangement means no rearrangement means it will be SN1. It will be what? The product will be same in SN1 as well as SN2. Is that clear? So the answer is third one. Thank you.